Alright, so here we have a trig equation to solve, and we got a problem right away, right? We have a cosine and a sine. Not only do we have a cosine of 2x, we have a cosine and a sine, we have cosine 2x sine x, right? So the arguments are different. We have two different trig functions, which are a little bit more difficult to deal with. So the goal would be first to get one trig function, okay? So that's when a lot of times we'll use identities. So what I want to think about is identities for cosine 2x, because I don't really have a lot for just sine x. So cosine 2x, I know that I have a few identities here. Let me show you those. Your double angle identities, right? So you're looking at, remember for cosine there's several. So I want to choose the one that's going to work best, and I think this one is the one I want, right? Because that's the only guy that has only a sine function in it. So if I replace cosine 2x with 1 minus 2 sine squared x, then I get the following equation: 1 minus sine x equals 1 minus 2 sine squared x. And the good news is I got everything in sine now, right? So I think what I want to do next is to set everything equal to 0. Get everything on one side, because this looks like one of those guys that'll factor, right? So I'm going to add 2 sine x to both sides, 2 sine squared x, I should say. This guy is still over here on the left, minus sine x. And then the next step, well, let me go ahead and write it out. I still have equals 1, and over here I still had that 1, right? 1 plus. So this 1 is still there, this 1 is still there, and then I'll subtract 1 from both sides, and of course that would give me, let me come down underneath my identities, that'll give me 2 sine squared x minus sine x equals 0. So now I want to factor, so I can factor out a sine x. That gives me 2 sine x, 2 sine x minus 1 equals 0. And now I know that I can set each of these guys to 0 and find solutions. Sine x equals 0, 2 sine x minus 1 equals 0. Solve this for sine x, so I get sine x equals 1/2 and sine x equals 0. Okay, so we want to find these over the interval 0, 2 pi. So in this case I think I can just figure out what the solutions are. Of course, for this one, the sine of 0 equals 0, and the sine of pi equals 0. Right? By now we should have a pretty good idea of what these special angles are and their sine values. Same goes with this one. Sine's positive in quadrant 1 and quadrant 2. Right? So you should know by now that the sine of 60 degrees, the sine of 30 degrees is 1/2. Right? So that's my first answer. Pi over 6. Since they're giving us the range, the allowable range for solutions in radians, and then that pi over 6 reference angle in quadrant 2, which would be 5 pi over 6. And those are the 4 solutions for this problem.